Hi there. In the previous video I went through the results for the derivatives for the inverse trigonometric functions, and I also went through the derivations of these results. So if you haven't seen or if you haven't watched that video, I would encourage you to watch it. Okay. Now in this video I'm going to go through some examples in terms of how these results are applied. But before I go through the examples, let me give you some additional results to help us with these examples. So let me call these additional results. Let's take a red pen and a ruler, underline this. So the first result, I'm going to name that result number 1. That is the result which is based on the derivative of the inverse sine function, or sine inverse x. So remember, in the previous video I said that if y is sine inverse x, dy by dx is 1 over the root 1 minus x squared. Now this result that I'm going to write down is based on that result. So if y is equal to a sine inverse ux, so what is a? So where a is a constant and ux is a function of x. Okay, so to get the derivative, so dy by dx, I'm going to be using the chain rule. Okay, so let me go through the steps involved. So in step 1, by the chain rule, dy by dx is dy by du times du over dx. And now in step 2, I'm going to work out dy by du. So y is equal to a sine inverse u. So my u is shorthand for ux. So let me make that as a note. So dy by du. Now bearing in mind a is a constant, if I differentiate sine inverse u with respect to u, and bearing in mind the standard result for sine inverse x, okay, we're going to have a divided by the root of 1 minus u squared. Okay, so I'm just differentiating with respect to u. Okay, and finally in step 3, if I replace dy by du by the result here, I'm going to have dy by dx, and that is equal to dy by du, which is a divided by the root 1 minus u squared, multiplied by du over dx. So multiply by du by dx. Okay, so this is the result for when you differentiate a sine inverse ux. A is a constant when using this result, and ux is any function of x. Okay, so let me go through the second result. So this is based on y equals cos inverse x. So if y is equal to a cos inverse ux, and let's go through the derivation for this result, for the derivative. So in step 1, let's repeat the stages. I'm going to use the chain rule. So by chain rule, dy by dx, that is dy by du times du over dx. So that's going to take me to step 2. And in step 2, as I've done in the previous derivation, let me calculate dy by du. So from here, y is equal to a cos inverse u, and once again u is shorthand for ux. So if I differentiate this with respect to u, dy by du will be, so based on the standard result for cos inverse x, if y equals cos inverse x, dy by dx is minus 1 over the root 1 minus x squared. So based on this standard result, if y is equal to a cos inverse u and a is a constant, dy by du will be minus a divided by the root of 1 minus u squared. Okay, so that's dy by du. So in step 3, final step, let me replace dy by du by this outcome here. So dy by dx is dy by du, which is minus a over the root of 1 minus u squared times du by dx. So this is the result for the derivative of a function of the form a cos inverse ux, and once again you can only use this result if a is a constant. Okay. Finally, number 3, the results involving tan inverse. So if y is a tan inverse ux, okay, so let me go through this result. So let's get the result for the derivative using the chain rule. So step 1 by chain rule. So dy by dx, that is dy over du times du over dx. And as you've seen before, I'm going to calculate dy by du as a side calculation. Okay, so let me calculate dy by du as a side calculation. So y is a tan inverse u and u is ux. So if I differentiate with respect to u, so if we calculate dy by du, so remember the standard result, if y is tan inverse x, dy by dx is 1 over 1 plus x squared. So that implies if y is a tan inverse u, and bearing in mind a is a constant, dy by du is a divided by 1 plus u squared. Okay? So further to that, so final step, step 3, if I replace dy by du by this result here, for dy by du, I'm going to have dy by dx, and that is equal to dy by du, which is a over 1 plus u squared, multiplied by du over dx. So that is the result for the derivative of a tan inverse ux, and a must be a constant in order for you to use this result. Okay? So if a is a constant, we can use the chain rule related results for the derivatives. However, if a isn't a constant, we may need to use either the product or quotient. Okay? So if a is a constant, we can use these chain rule related results, and repeat if a is not a constant, so if a is a function of x, we need to use either the product rule or the quotient rule. Okay? So let's try some examples. So example number 1. Let me take a red pen and a ruler. Let me underline this. So example number 1, question is, let's find dy over dx. So let's go through a number of examples. So in part A, so let's try some examples. Y is equal to 2 sine inverse x squared. So y is equal to 2 sine inverse x squared. Okay? Now, although I went through the results, and although I went through how these results are derived and how they arise, okay, don't memorize results, okay? So as long as you know the standard results for sine inverse, cos inverse, as well as tan inverse, okay, just appreciate what the result is saying. So let's talk through one of them. So if y is a sine inverse ux, provided that a is a constant, dy by dx will be a, which is a constant, so leave the a as it is, over the root of 1 minus u squared, so that comes from the standard result for the derivative of sine inverse, but you need to multiply by du over dx. So you need to multiply by, in other words, d by dx of the u term, and the u term comes from this term over here in the inverse trigonometric function. So for all of these results, u is this term that appears here as part of the inverse trigonometric function. Okay, so we only do this if a is a constant, remember. If a is a function of x, it's either product or quotient rule. Okay, so let's have a look at this one here. So first of all, I'm looking at the term in front of the function. So the term in front of the function a is 2. 2's a constant, so we can use the chain rule related results. So dy by dx, that is equal to, leave the 2 as it is, so it's a 2 over. Remember the standard result for the inverse sine derivative, it's 1 over the root, 1 minus. Replace, remember it's 1 minus and it's a u squared. So ru is x squared. So it's an x squared squared. Okay? So remember a divided by the root, 1 minus u squared. Ru is x squared. So it's an x squared with another squared. But remember we need to multiply by d by dx of u, and u is x squared. Okay, so this term over here, let me take a green pen, this is ru, or ru of x. Okay, so you could also link that to here, it's a d by dx of u. Okay, so now it's just a matter of tidying this up. So dy by dx will be d by dx of x squared, so when I differentiate x squared, it's 2x. 2x times 2, 4x, divided by the root of 1 minus, and x squared squared is x to the 4. So that should be the outcome of the first part, part A. So let's try another one. So part B. So if y is equal to, okay, let me make up one. So 5 cos inverse of, let's say, x to the power 3. So 5 cos inverse x to the power 3. So first of all, I look at the term in front of the inverse function. So the term in front of the function, a is 5. 5 is a constant, so I can use the chain rule related result. So dy by dx is, so remember 5 is a constant, leave the 5 alone. And remember the standard result for cos inverse. The derivative of cos inverse is a minus 1 over, and it's a minus 1 over the root, 1 minus. Now the u in this case is this term. So u as always, or ux, is x cubed. So it's the root of 1 minus u, which is x cubed, and don't forget to square, okay? Multiplied by d by dx of u, and u is x cubed, as I've noted. Okay, so now it's just a case of tidying this up. D by dx of x cubed, that is 3x squared. So when I simplify, dy by dx will be minus 5 times 3x squared is minus 15x squared, divided by the root of, and 1 minus under the root, x to the power 3 to the power 2 is x to the power 6. Okay? So that completes this example. Right, let's try another one. So here is a part C. Okay, so part C, let's differentiate y is equal to 2x. Okay, so 2x tan inverse 2x. So y is equal to 2x tan inverse 2x. So first of all, the term in front of my function is 2x. So that is our a term. A is 2x. Now, in this case, it's not a constant. Okay, so a is a function of x. It's not a constant. So you can't use the chain rule related result. So the only other method is either the product or the quotient. Since I have a product of two functions, it's going to be product rule. Okay. So I'm going to take u to be 2x and v to be the remaining term tan inverse 2x. So let me repeat. The term in front of the function is 2x. 2x is not a constant, so you can't use the chain rule related result. You need to use either the product or the quotient. Since I've got a product of two functions, it's got to be product rule. So step number 1, by product rule. So let me write down the rule to remind ourselves. dy by dx is v du by dx plus u dv over dx. Now, in step number 2, let me do a side calculation. So I need du over dx. I also need dv by dx. So u, I've taken that to be 2x. So du by dx. So when I differentiate 2x, it's 2. Let me do another side calculation alongside this one. So v is tan inverse 2x. Let's think about dv over dx. So the term in front of my function is 1. So a is 1. 1 is a constant, so I can use the chain rule related result for the inverse function. Okay? So remember, when I differentiate tan inverse, it's 1 over, and it's a 1 over 1 plus. Okay, and remember ux is this term, so u is 2x, so it's a 1 over 1 plus u squared. U is 2x, so it's a 2x squared. But remember, don't forget, you need to multiply by d by dx of ux, and ux is 2x. Okay, so let's tidy this up. So dv over dx, that is equal to d by dx of 2x, that's simply 2. 2 times the 1 is 2, divided by 1 plus, and 2x with a squared is 4x squared when simplified. Okay, so that is step number 2, and step number 3, final step. Let's replace du by dx and dv over dx as well as u and v in our product rule. So dy by dx is v, which is tan inverse 2x, multiplied by du over dx being 2, plus u, which is 2x, multiplied by dv over dx, which is 2 over 1 plus 4x squared. So 2 divided by 1 plus 4x squared. So all what needs to be done is to simplify. So if I expand the brackets, 2 times tan inverse 2x is 2 tan inverse 2x plus 2 times 2x is 4x over 1 plus 4x squared. And you could go one stage further. If I take a common factor of 2, I'm going to be left with tan inverse 2x plus 2x divided by 1 plus 4x squared. Okay, so that should be the solution to part C. Okay, so here are the steps involved for part C. So remember, unlike the previous parts, if A is not a constant, it's going to be product or quotient rule, but since we've got a product of two functions, we've used the product rule. Okay. However, if A is a constant, you can use the chain rule related results as we've done in parts A and B. Okay. So that ends these examples, and that sadly ends this video. So I hope you enjoyed this video. Do related practice questions, and a like is very much appreciated. So if you enjoyed this video, click on that like icon, and I hope to see you soon. Thank you.